Okay, so
Listen.
first I wanted to know what I should try. So I did the 1, 2. There's 2 sign changes. So there could be 1 or 2 or 0 positive real solutions. And then there's also, if I switch the signs, it would be negative x to the third minus 5x squared minus 4x plus 10. And there's only one sign change. So there's 1 negative real solution. So I'm going to start with my negatives if I have it. And then
I like that. So I like that Amelia checked to see how many negative real solutions she has and how many positive real. So then it's smart because now she's saying, I'm going to check all my negatives first. I like that. Continue.
And then we have to do P over Q for the numbers that could be of real solutions. And since Q is 1, we know that they're all over 1. So it would be positive or negative 1, positive or negative 2, positive or negative 5, and positive or negative 10.
Can we push, not push pause actually, but just everybody, does anyone have a question for her so far? Yes.
Because, well, you have to switch signs of the x's to find out whether it has the negative real. And then where you have negative x squared, that's negative x times negative x, which equals x squared. And then the 10 doesn't have an x after it. So.
Great. Any others? Okay, continue, Amelia, doing great.
Okay, so gotta start testing them in our thing, and I like to test using the division thing.
Synthetic division, that's the smartest way, really.
Synthetic division, and since I got the 1 negative, I'm gonna do negative first. So I know it's 1, negative 5, 4, 10, and then negative 1, right? So I'm gonna start with my smallest. 0 and then 1, minus 1, minus 6, 6, 10, minus 10, and then 0. So I know that negative 1, sorry, that's a funky pen. Negative 1 is a factor of this. So I already know that one of the roots is negative 1. And then I gotta see if 1x squared minus 6x plus 10 will equal, will be able to be factored. And I know that it has to be multiplied 10, add to 6. You can't do that because it would be 1 times 10, which would be 11, or negative 11, or 2 times 5, which would be 10, but 2 plus 5 is 7, or negative 7. So, you know, a negative 1 is our only factor.
Does that make sense of what she just said?
Yeah.
Her quadratic didn't factor, so then she knew that must be the only rational root. Amelia, what Amelia's really good at, I noticed, thank you so much. You explained that perfectly. What Amelia's really good at, and I think what helps her in this class to do really well, is she pays attention to the little details. She never leaves out a little detail, like when she put this 0 here. She just pays attention, and something I say sinks in, and then it stays. So just make sure, like, take her example. A lot of you are really good at this. And then soak in every little thing, kind of. And the little details matter in secondary math 3 like no other. Okay, awesome. So, guys, your 2-, I'm going to push pause real quick. Okay, so today is 2-7. We're going to be talking about the fundamental theorem of algebra. So, I'm going to just read some of this here. So you can factor any polynomial of degree n into n linear factors. But sometimes the factors will involve imaginary numbers. So remember how, like, we've been doing that. We've been solving something and then going backwards, writing them as factors. Even if we got like 7i and negative 7i, like on the quiz, we could rewrite it as linear factors. So that's what this is saying. Even if we have imaginary numbers, we can technically rewrite it as linear factors. So the degree of a polynomial equation tells you how many roots the equation has, which we kind of already know that. The highest degree of a polynomial will tell you how many roots an equation has. So it's easy to see graphically that every polynomial function of degree 1 has a single zero. So look at a line, guys. Won't a line, it continues upward forever, downward forever. Won't it eventually cross the x-axis somewhere? Yeah. And only in one spot. So where it crosses the x-axis will be where the zero is. Now, so with a quadratic, there are three possibilities for a polynomial of degree 2. They correspond to these three graphs, which we already know. So this one has two real zeros, x squared minus 4. It crosses the x-axis at, I can't even see, that's kind of small. Negative 2 and 2, right, everybody? Yeah. And then we can also have a quadratic that only touches down and bounces back up. That still has two solutions, correct? But it's just with a multiplicity of 2. So this would be x is equal to 1 with a multiplicity of 2. However, it still has, even though it has one real zero, it has a multiplicity of 2. So technically we have two solutions. And then even though this quadratic never crosses the x-axis, we do have two solutions. They're just not real solutions. So basically every quadratic function has two roots. Degree 2 means two solutions. Correct, everybody? That is what the fundamental theorem of algebra is. It's simply that. Whoa. Oh. Oh, weird. Oh, that. Oh, it's my marker. I was like so confused. Okay, so that is all the fundamental theorem of algebra says. Basically, in simple terms, the highest degree will be the number of solutions you have. Does everybody understand? So if it's degree 5th is the highest degree, we have how many solutions? 5. If it's degree 4, we have 4 solutions. If it's degree 3, we have 3 solutions. That's all that the fundamental theorem of algebra says. No, they have 5 solutions. Great question. No matter what, degree 2 has 2 solutions. No matter what, degree 3 has 3 solutions. And so on and so forth. Now, so I'm just going to read this, which it is what I just said. A polynomial of degree n greater than 1, if the polynomial is set equal to 0, has exactly n roots, including multiple and complex roots. So like, for example, even though x minus 4 squared technically has solutions x equal 4, it technically has multiple root, right? That's a multiple root because it's x equals 4 with a multiplicity of 2. Does everybody understand? Now a complex root, first of all, we need to know what complex root is. So note, complex numbers. Think back to secondary math 2. A complex number has the form a plus bi, where a is the real part and bi is the imaginary. Whoa, I can't think and spell. Imaginary. So where a is the real part and bi is the imaginary part. So everybody look right here. These are just examples of complex numbers. 3 plus 2i, where 3 is the real part, 2i is the imaginary part. 4 is actually a complex number because technically that's 4 plus 0i. Does everybody understand? So even 4 is still a complex number. A half minus 7i, there's our real part, there's our imaginary part. 6i is a complex number because that's technically 0 plus 6i, where 0 would be the real part and 6i the imaginary. So guys, is it making a connection that any number is considered a complex number? Yes, okay? Okay, so complex root are any type of root. If it can be any number, then if I say to you how many complex roots, that means how many roots, period, end of story. That would be, it's depending on the highest degree, how many we're going to have. Okay, so let's see number 1. So it says, without using a calculator, find all the complex roots of the equation. So first of all, let's just talk about how many complex roots we're going to have. Well, the fundamental theorem of algebra says, and complex roots just mean any type of solution, because a complex number is anything. So, how many solutions are we going to have? 5. We're going to have 5 complex roots, or 5 solutions. Okay, awesome. Now it says find the roots. So on the last test, we were finding them by factoring a lot of times. If there is something that you're able to factor out, you will. But look at this polynomial. There's no GCF, correct? There's no greatest common factor. We haven't learned a method besides the rational root theorem. So we're going to find all the roots by listing out, okay, I don't know any other way but listing out my possible rational roots. So we're going to use the rational root theorem. So in this one, this is Q, this is P, correct? Everybody?
Right, we have to actually find them.
Yeah, because it says, what are the complex roots? So we have to find all 5 roots. It's not as hard as it seems. We've got it. Here we go. So we're going to list out all P over Q's, because that's really the only way we know to tackle this problem right now. So P, factors of P are plus and minus 1 and plus and minus 5, correct? Q is plus and minus 1. So the only possible rational roots are P divided by Q, so 1 and 5, because both divided by 1 are themselves. So plus or minus 1 or plus and minus 5. Is everybody comfortable?
Yep.
Any questions? Okay, so what I'm going to do is today I'm going to use, because it's much easier than plugging in, I'm going to use synthetic division to test to see if these are roots, because that's a lot quicker and less room for error than plugging in. Okay, so I'm going to go with, and I'm just going to plug in positive 1, and I'm going to put in my synthetic division. Now you got to check though, because remember with synthetic division, if you're missing a variable, you've got to put in a 0. We're not in this one. So we put our coefficients, 1, -3, -8, -8, -9, and -5. So we're going to test to see if this is a root by looking at the remainder. So we drop down 1. 1 times 1 is 1. We add straight down. -2. -2 times 1 is -2. We add straight down and get -10. Now keep in mind, if you want to just watch and not take down the note, or like, it's up to you. But if I do it on the board, I don't expect you to show work. So if you want to just watch, you can. So -10 times 1 is -10. We add straight down and get -18, correct? -18 times 1 is, and then we add straight down. Are we gonna end up with a remainder of 0? Let's think logically, no. So I'm gonna stop. Why keep going with it, right? That's what we're trying to test here. So I'm gonna go on and I'm gonna test -1. So I'm gonna test -1 instead. And I'm just gonna draw a new one because I don't want to mess up. 1, -3, -8, -8, -9, -5. So we drop this down, we get 1. 1 times -1 is -1. We add straight down -4. -4 times -1 is 4. We add straight down and we get -4, correct? -4 times -1 is positive 4. We add straight down and get -4. -4 times -1 is positive 4. We add straight down and get -5. -5 times -1 is 5. We add straight down and get a remainder of 0. Sweet. So -1 is definitely a solution, correct? Everybody?
Yeah.
Okay, awesome. So that's just taking us from degree 5 to degree 4, correct? Okay, so let's keep testing positive 5 and -5 because there's really nothing we know how to do with degree 4 unless it's, it just depends. But we right now have x to the 4th minus 4x to the 3rd minus 4x squared, right?
Yeah.
Minus 4x minus 5. So let's keep testing. So let's do positive 5. Synthetic division. So we put in our coefficients 1, -3, -8, -8, -9, -5. We drop this straight down, we get 1. 1 times 5 is 5. We add straight down and get 2, correct? Are we following?
Yeah.
2 times 5 is 10. Add straight down, get 2. 5 is 10. Add straight down, get a 2. 2 times 5 is 10. We add straight down and get 1. 1 times 5 is 5. We add straight down and get 0. Okay, so 5 was also a solution. So if we did synthetic division twice, that would take it from degree 5 to degree 3, 4 to degree 3 then, right? So that still isn't the best. We like it to be quadratic. So I'm just going to continue to test -5. So putting in -5, 1, -3, -8, -8, -9, -5. Is it going to come out? Let's see. 1 times -5 is -5. We add straight down and get -8, correct? -8 times -5 is 40. We add straight down and get, yep, 32. 32 times -5, and then this isn't going to come out, right? Okay, So we've got to look at this a little bit deeper here, but we're going to be able to do it, and I'll show you why. So if we know these are the two solutions, then we can do synthetic division twice, and we're going to have a degree 3, which is smaller than 5. So let's start from there, and then look at it and see if we know how to solve it. Okay? So here we go. We started here we did synthetic division once and got this, correct? So we have this new polynomial of x to the 4th minus 4x squared minus 4x cubed. Oh, that was cubed, right? Minus 4x squared minus 4x minus 5. So now we're going to do synthetic division with the other root with those new coefficients. So I'm going to erase this to give myself some room. Yeah, you're going to use the other root now. So I'm going to do synthetic division again with the other root that we know, 5, because then we're going to get a remainder of 0 for sure, which is what we want, right? So I'm going to use 5, and I'm going to do synthetic division, but with these new values. We're going to take it from degree 4 to degree 3. So we have a 1, a negative 4, a negative 4, a negative 4, and a negative 5. The remainder is gone. There wasn't a remainder. So we drop down 1. 1 times 5 is 5. We add straight down, we get 1, correct? 1 times 5 is 5. We add straight down and get 1. 1 times 5 is 5. We add straight down and get 1. 1 times 5 is 5. We add straight down and get 0. We better get 0 because 5 was a root. So now we have remainder, constant.
That was the negative one.
This.
That's fine.
No, we don't do opposite. Remember when we were changing it to opposite, it's because we were doing synthetic division with something like x plus 4. So we use the root of negative 4. So that's why we don't change these, because those are the roots.
Saying is like, so you divided the first one.
Yep, we got a remainder of 0. Then I went and found that 5 was definitely a root by doing synthetic division again. You had a question?
Oh, I'm good.
Okay, so then I said I know 5's a root. So I'm going to do synthetic division twice, but I'm going to do it with, so you do synthetic division once and you get a 4th degree, right? Now if we do synthetic division with this polynomial, we're going to get a degree 3, which will make it smaller. So you have to use the other root. You won't use the same one again, unless it had a multiplicity of 2, which we don't know at this point. Okay, so we have a remainder of 0 constant x squared x cubed. So we have the polynomial x cubed plus x squared plus x plus 1 equals 0. Now let's think. Do we know a method to solve something like this?
Yeah.
Factoring by grouping. There's 4 terms. So we try factoring by grouping. So we're going to group the first 2 terms. We're going to group the second 2 terms and factor out the greatest thing in common in each group. So this is going to factor out an x squared, correct?
Yes.
So we're pulling out x squared and then divide by x squared, divide by x squared. Some of you missed this on the test. We'll be left with x plus 1. In common here, don't say nothing, guys. Think on an advanced level. Isn't there a 1 in common?
Yeah.
We're factoring out positive 1. So then left is x plus 1. We know we've done it correctly because our safe haven's the same. So we'll factor out x plus 1. And left is x squared plus 1. Right? Now how do we solve that? Isn't it, if it was factorable, then we can set our factors equal to 0 and solve. So we're going to set x plus 1 equal to 0. We're going to set x squared plus 1 equal to 0. Now solve for x in each case. So when we subtract 1, x is equal to negative 1. Well, didn't we already have that once?
Yeah.
So that's a multiplicity of 2. We have a 5. And then our last 2 solutions here, solving for x, we'd subtract 1. So x squared is equal to negative 1. What would we do next? Square root both sides of the equation. So x is equal to plus and minus I. I square root of 1 is just I times 1. So we get I. So look, let's count how many solutions we have. We better have 5 or we've done something wrong. The fundamental theorem of algebra says we have 5. We have 1, 2, imaginary. 3, 4, 5. We have 5 solutions. So because we're in secondary math 3 honors, we'll write it like this. X is equal to -1 with a multiplicity of 2, and then x is equal to 5, and x is equal to I, and x is equal to -I. Questions? Okay, we'll do another one. You sure?
Yeah.
Okay, let's go. One more, here we go. Number 2, without using a calculator, find all the complex roots. So we know that we're going to have 3 roots total, which are 3 complex roots, right? Degree 3. So we're going to list out, there's no way, because technically we can solve anyway. So is there a easy method here? Now I'm seeing it. Grouping, right? Let's go for it. Let's just do that then. Group the first 2 terms, group the second 2 terms. Greatest thing in common here is x squared. So then left would be x minus 2, correct? If it didn't factor by grouping, we would do p over q and go through the process. So let's just do the easiest method. So what's in common here? Positive 4, correct? Left will be x minus 2. Oh, it did factor by grouping because we have our inner parentheses is the same, so we'll factor out x minus 2. So then left is x squared plus 4. Correct? Now we know since it's factorable, we have the factors, we'll set each of those equal to 0 and solve. So I did this the hard way on the worksheet. We'd add 2, so x is equal to 2. Some of you need to actually do the algebra because you just think you can see it in your head and you were getting them wrong on the test. So let's do the math on this one. minus 4. X squared is equal to -4. Now what will we do? Square root both sides of the equation. So we get x is equal to, root cancels out with power, the square root of -1 times 4. The square root of 4 is 2. Square root of -1 is I. So we're going to get plus and minus 2i. Now those are all of our solutions. We have 1, 2, 3 solutions, which we said we would. That one was easy, right? We will use the most appropriate method. If we don't have to do p over q, we won't. That's our last resort. Number 3, and then I'm going to let you just go for it. Okay,
Like
so
the rest of the homework?
no, but for a while. But we're really not learning anything a whole lot new. So it's just practicing. Here we go. So looking at this one, 4 terms could be factored by grouping. You could try, but it's not going to work, right? Look at it. We factor out x squared. So if we factor out x squared, we would be left with x plus 1. And then if we factor out a -1 here, because there's a negative in front, that would leave us with x plus 2. So it wasn't solvable by factoring by grouping. Good try though, right? So we'd say, oh no, I guess that means we have to use the rational root theorem and go through the process. Luckily, this one's pretty good. Here's my q, my p is 2, so this one's actually going to be pretty simple. Let's list out all possible p divided by q. Won't that be plus and minus 1 and plus and minus 2? Divided by 1. So those are our possibles. I'm going to go ahead and do positive. I'm just going to do synthetic division and start testing these. Now careful, we have all of the degrees of x's, so we don't have to put in zeros. 1, 1, -1, 2. Drop down 1. 1 times 1 is 1. Add straight down is 2. 2 times 1 is 2. Add straight down is 1 times 1 is 1. We get 3, correct? So this remainder is not 0, so we'd say no. Let's move on. -1. So 1, 1, -1, 2. Let's drop this down. 1 times -1 is -1. Add straight down is 0. 0 times -1, 0. Add straight down is -1. -1 times -1 is 1. Add straight down is 3. So we get a no, correct? Did I make an error somewhere? Okay, let's do 2. 1, 1, -1, 2. 1 times 2 is 2. Add straight down is 3 is 6. Add straight down is 5. Are we going to get a remainder of no? Okay, we're almost there. Let's test -2. 1, 1, -1, 2. We drop this down 1. 1 times -2 is -2. Add straight down is -1, correct? -1 times -2 is +2. Add straight down, we get 1. 1 times -2 is -2. We add straight down and get 0. Okay, we know that -2 is a solution. Remainder constant x squared. So we have a quadratic now. We have x squared minus x plus 1 equals 0. So now we would say, is it factorable? If yes, let's solve by factoring. If not, then we'll quadratic formula. So the difference between today and yesterday is today I'm saying find all the roots. Yesterday I said find all the rational. So yesterday you would have just simply said, does this factor? If the answer is yes, you'd keep going. If no, you're done. That would have been your only rational root. Today I'm saying give me any root. So we keep going. Does everybody understand? Okay, so let's see if this factors. Well, multiplies to be 1 and adds up to be -1. Nothing. Right? A times C, guys?
Yep.
So let's quadratic formula. So we have x is equal to the opposite of b, which would be +1, plus or minus the square root of b squared, -1 squared, minus 4 times a, which is 1, times c, which is 1, all over 2 times a, which is 1. So we're simplifying it. X is equal to 1, plus or minus the square root. Remember, just a reminder, we only type that part into our calculator. If we're using the quadratic formula, it's because that didn't come out even. Came out imaginary or it comes out irrational. So we know that we only type that part in. We get 1 minus 4, which is -3, correct? Did you get -3 when you typed that in? And then that's all over 2. So then you'd say to yourself, this is the point where I simplify underneath the square root. So won't it be an I on the outside? That's it, right? So we get 1 plus or minus I square roots of 3 all over 2. So we have those 2 imaginary solutions, and then we have our 1 real solution. Was it degree 3 to begin with? Yeah, so we have 3 roots, and that's correct. The fundamental theorem of algebra says we will have 3. Does everybody understand how to do it? Okay, I'll give you till lunch to practice those. So these are the ones you're doing, 1 through 6. So we're going to use the most appropriate method to find the zeros. So the first thing we always do, no matter what, is say, is there a greatest common factor? So on number 7, we're going to find the zeros. So we do have a greatest common factor. What would we factor?
5x.
We'll pull out a 5x, then left is x squared minus 1, correct? So now this one's easiest to be solved by factoring. So we know the fundamental theorem of algebra says that we should have 3 solutions. So we set 5x equal to 0. We set x squared minus 1 equal to 0. Solve for x in each case. Divide by 5. So x is equal to 0. There's one of our solutions. And then we add 1. X squared is 1. Square root it. Root cancels out power. X is equal to plus and minus 1. Okay, questions?
Wait,
Yeah.
so let's do there's what? 5 zeros, 1 zero.
Because we go up the highest degree, correct? So there's 3 zeros. That's what the fundamental theorem of algebra says. So it's not the coefficient in front of the variable, it's the degree. All right, how about number 9? Let's do that one. Find all the zeros. Once again, we're going to do it using the most appropriate method. Isn't there a 2x in common?
Yeah.
Factor out 2x. Guys, divide by 2x, divide by 2x, divide by 2x. So we're going to have 6x squared minus x, correct? And then minus, don't say nothing, 1. Now now we have a linear and a quadratic, so we'll set 2x equal to 0. We'll set 6x squared minus x minus 1 equal to 0, and we'll solve it. Divide by 2, so x is equal to 0. And then over here, what multiplies to be -6, I'm going to solve by factoring if possible, and adds up to be -1. -3 times 2, -3 plus 2. So then we drop our n term down, 6x squared, I'm going to put in minus 3x plus 2x. We drop down -1. We're factoring by grouping. And common here is 3x. Left is x minus 1, correct? Factor out of 1. Nothing more in common besides 1. Uh-oh, what did I miss? Okay. So that's a good way to check that we've done something wrong. So divide by 3x, divide by 3x. So that's 2x minus 1. And then we pull out positive 1, and left is 2x minus 1. So once again, I was able to make a mistake and check it due to the safe haven. So I factor out 2x minus 1. Then left is 3x plus 1, correct? So we get x is equal to, you guys do the math. You'd add 1, divide by 2, positive a half. A lot of people are getting those wrong. We would subtract 1, divide by 3, negative a third. Now guys, we have 3 solutions, which should have been true because the fundamental theorem of algebra says if the number of roots we're going to have is the highest degree. Okay, you guys are good. Do 7 through 12. I won't do any more because I think you're good. Hey guys, let's not have to get a stating chart. Everybody back up here. We don't have time to waste for me waiting and stuff. So it says, for each equation, state the number of complex roots, state the number of complex roots, which we talked about, the possible number of real roots, and the possible rational roots. So we're going to do 13. So first of all, the possible number of complex roots, and we're going to keep it nice and orderly. Complex is the highest degree, correct? It's how many roots are we going to have total, right? So we're going to do the highest degree too, correct, everybody? Okay, awesome. And then it says, state the possible number of real roots. So real roots are where it crosses the x-axis. That's what we learned yesterday with Descartes' rule, or 2 days ago with Descartes' rule of signs. So this is what I want you to, this is what you're going to need to do. You're going to see how many positive real roots you can have using Descartes' rule of signs. So positive, it's no sign changes, correct? So we have no positive real. Negative real. If we plug in a negative x, that's going to be 2 times negative x squared plus 5 times negative x plus 3. So won't that simplify to be positive 2x squared and then minus 5x plus 3? So there's 2 sign changes. So there's either 2 or no real negative roots. So it says the possible number of real roots. So isn't there 2 possible? So that's what we would say for real roots, is there's 2 possible. And then we'll answer the last one, the possible rational roots. So we'll be doing P over Q. So P plus and minus 3 plus and minus 1, correct? And then Q is plus and minus 1, plus and minus 2. So the possible rational roots are all P over Q's. So 1 over 1 is 1. 1 over 2 is 2. Sorry, 1 over 2 is 1/2. 3 over 1 is 3. And then 3 over 2 is 3/2. So now there's our answers. Complex roots are just any root. So we know it's going to be the amount of the highest degree. Yes. It doesn't say the number, it says and the possible rational roots. So good point. If it said the number of possible rational roots, we would say 1, 2, 3, 4, 5, 6, 7, 8. But it wants to know the possible rational roots. We tested it with Descartes' rule of signs. It could be 0 as well. So there are 2 possible real roots. Let's do another one. Pay attention to the little details. I think you guys kind of zone out and kind of halfway pay attention. No, we didn't say 2 or 0 is a possible real root. We said there are either 2 real roots, 2 negative real roots, or 0 negative. But not that 0 and negative 2 is a root. That was what we learned last time, Descartes' rule of signs. It's just how many there could be, not the roots, if that makes sense. Okay, let's do 21. Here we go. So we're going to answer the complex roots. So how many complex roots? That's just the fundamental theorem of algebra. That's the highest degree because it's any root. So isn't this definitely going to have 5 solutions? So the possible complex roots is definitely 5. Now the possible number of real roots. Possible. We're going to test the positive and negative. So I'm going to go off to the side and I'm going to say how many possible positive real roots could we have using Descartes' rule of signs. So positive to negative, there's 1 sign change, negative to positive, 2 sign change, positive to negative, 3, negative to positive, 4, positive to negative is 5. So, and I'm going to do this up on the side, for positive real roots, there's either 5, 3, or 1 positive real root, correct? It goes down in 2s. Now let's plug in negative x to see how many negative real roots we could have. So won't this become a negative? Negative 4x to the 5th. Because if I plug in negative x to the 5th, won't that be a negative 1 in the front, guys? Now, careful here. If I plug in negative x to the 4th, won't that make it positive? So this is still negative right here. Minus 5x to the 4th. Right here is going to become negative minus x cubed. This one's going to stay positive in here if I plug in negative x squared. So that's still minus 2x squared. And it's going to become minus 2x minus 6. So how many sign changes? None. So there were zero negative. So how many possible, we've got to answer this correctly. It says the possible number of real roots. Couldn't we have 5? So that's what we would put. Yeah, because it says, and now list the possible rational roots. So we've got to list out plus and minus 1, plus and minus, this is my Q, this is my P. So plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 6. And then 2, plus and minus 1, plus and minus 2, and plus and minus 4, correct? Yep. So all possible P over Q. So let's go like this. Let's think of it like this. All of these divided by 1 are just themselves. So those are all going to be our possibilities. Now let's do 2 divided by 2, which is 1. 2 divided by 4 is a half, correct? So we have to do plus and minus a half. 3 divided by 1, we've already got it. 3 divided by 2, we need that one. 3 divided by 4, we need that one. 6 divided by 1 is 6, we've listed it. 6 over 2 is 3, we've listed it. 6 over 4 is 3 halves. So these are the only possible rational roots. We're just listing out possibilities here. Questions? Ready to practice? Okay, I'm not going to make you do all of those because I think that if you do just the odds on 13 through 20, so 13 through 23, just do odds. So this column on this side. That's all you have to do. You can cross out the evens just on that little piece. So I'll give you a second to practice some of those. Oh, well, you know what? These ones are really easy, so let's just finish off these. So look at number 25 with me really quick. This one's just, all you have to do is look with your eyeballs to answer the question. It says, find the number of complex roots for the equation. What is it? 8. The fundamental theorem of algebra says there will be 8 solutions. So we'd say 8. There are 8 complex roots. Okay, so this is what you're doing. 13 through 24 odds only, and then do all of 26 through 30. Ready, set, go. Okay, let's do number 32. Here we go. Let's read the instructions. It says, find the zeros of the function. So we're going to solve it, correct? The fundamental theorem of algebra says that we should have 3 solutions. Now, I'm going to solve this using the most appropriate method. So looking at this one, there's 4 terms. We could try factoring by grouping, correct? Factoring by grouping. So will that one work? Yeah. Nope, it's not going to come out right? Or is it? It will? Sweet. Then let's do it. So we group the first two terms, group the second two terms. What's the greatest thing in common? 2x squared. So then left is x minus 4, correct? And common here is positive 18. It has to be. So then is 72 divided by 18 4? Okay, sweet. X minus 4. So this one is easiest by grouping. So now we'll factor out x minus 4. Left is 2x squared plus 18. And now we'll set each of those equal to 0. So we have x minus 4 equals 0. 2x squared plus 18 equals 0. Solve for x in each case. X equals 4. There's one of our solutions. Use your algebra to do this. Nope, see, you did it in your head and got it wrong. That's why we, most of the time, just don't do it in your head. Minus 18, minus 18. So we have x squared. 2x squared is equal to negative 18. Divide by 2, divide by 2. X squared is equal to negative 9. Square root it, square root it. So x is equal to plus and minus 3i, correct? We have three solutions that better be true according to the fundamental theorem of algebra. Let's do 36. Okay, let's find all the zeros. Can we solve this one by factoring? We could try factoring by grouping, but then it wouldn't work. So let me say, well, it looks like the only way we can solve it is to do P over Q, right? So possible P's, so this is our Q, this is our P. So plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 4, plus and minus 6, plus and minus 12, and they're all divided by 1, correct? So that's P over Q. So I'm going to do synthetic division, and we could use Descartes' rule of signs to help us determine which way we should test first. But do you want to do that? Yes or no? I don't care. Do you want to just start testing? Okay. So let's test 1. So we have a 1, negative 2, negative 11, 12. Drop down our 1. 1 times 1 is 1. Add straight down is negative 1. And then you guys know how to continue solving, right? So if you want me to just let you work the rest of the time, that's what I'll do. We all feel confident we could continue this? No different than what we were doing at the beginning. You want to just finish that one? Well, because you're lazy. I jaded him deep. Called out the truth. I only speak truth. Okay, so then, yeah, if you'll participate. If not, I'm cool with not standing up here teaching. So we have negative 1, that's negative 12, right? Negative 12 times 1 is negative 12, 0. We know that 1 is the solution. So there's our quadratic, right? Remainder constant, x squared. X squared minus x minus 12 equals 0. Does it factor? Let's think advancedly. Multiplies to be negative 12 and adds it to be negative 1. No, you were right the first time. Negative 4 and 3. So this factors to be, we can quick factor it. X minus 4 times x plus 3, correct? So we get x is equal to 4 and x is equal to negative 3. There's our three solutions, which we should have 3. All right. I won't do any more than I think you're good.